Plastics. Love them or hate them, they are pretty much everywhere. Yes, everywhere. Even your poop isn't safe, and I can't imagine that being good for you. So, how did those plastics become so ubiquitous? Well, because we made them and we use them a lot. But specifically, what problems are they causing, and what can we do to fix our mess? Well, that's what this compilation is about. And we'll kick things off with why we're so bad at recycling the stuff in the first place. Here's Stefan with more.
Look around you right now. How much plastic is within reach? Plastic is literally everywhere. Scientists have found it in the deepest depths of the ocean and on top of the most remote mountain peaks. Since the end of World War II, we've produced more than 8 billion metric tons of plastic. Of all that, only about 9% has ever been recycled. But it's not just because humans are lazy or bad. So let's take a look at what makes something that's so vital to modern life also difficult to reuse. Think about a plastic water bottle, like the kind you might buy at an airport. It's estimated that around the world, people buy 1 million plastic bottles every minute. And it's easy to think of a plastic bottle as being made of a single thing, which is the first problem. We use the generic word plastic to refer to a bunch of chemicals that are actually really different. Broadly speaking, plastics are polymers, which is a fancy way of saying they're repeating chains of molecules. During their formation, they can be processed into arbitrary shapes, which is what gives them such a wide range of applications. Now, every plastic material falls into one of two groups, thermoplastics and thermosets. The individual links in a thermoplastic are held together by relatively weak chemical bonds. When the material is reheated, the molecules can break free from those bonds and take on a new shape. But in a thermoset, the polymer chains form intricate networks with tight bonds. Heating these materials enough to break the network destroys the plastic itself. So while thermosets can be very strong, they can be difficult to recycle. There are a lot of different types of thermoplastics in commercial products, but two of the ones most commonly seen in the United States are known as PET and HDPE. PET, or polyethylene terephthalate, is clear, can withstand moderate temperatures, and resists cracking, while HDPE, or high-density polyethylene, can survive more extreme temperatures, but generally lacks the transparency of PET. Both of these plastics are used for ordinary bottles, but the trouble is that not all recycling centers accept both of them, so you need to know what kind of plastic you're tossing out and what types your local recycler accepts in order to dispose of one correctly. Even then, you're probably still doing it wrong, because a single product often combines multiple kinds of plastic. For instance, the twist cap on that bottle made of PET can often be made of polypropylene, yet another type of plastic. And since most of us don't carefully disassemble our trash before getting rid of it, recycling plants need a way to separate all the plastics they receive. And it can be critical for this separation to be nearly perfect. For example, if the plastic PVC gets recycled, it can create acids that damage and discolor PET beyond repair. And all it takes is a single PVC bottle in a pallet of 10,000 PET ones to ruin the whole batch. To avoid these problems, recycling plants have a few ways to sort plastics. One approach is to use density. When immersed in water, PET sinks, while some other plastics float. Another option is heat. Different plastics become soft at different temperatures, so precisely heating the mixture can set the various materials apart. But since even a tiny bit of contamination can do a lot of damage, recycling properly gets expensive, sometimes too expensive to be worthwhile. For instance, in New York City, every ton of recyclables costs $200 more to recycle than it would cost to just toss in a landfill. But here's the thing. Even if we invented a process that magically and flawlessly sorted and processed every kind of plastic, recycling would still be hard. That's because unlike metal and glass, plastic degrades every time you recycle it. Aluminum, for instance, is an element, so no matter how many times you melt and rework it, you've still just got aluminum atoms. On the other hand, at the microscopic level, plastics are really long chains of molecules. For example, HDPE, one of the plastics we do recycle, can contain up to 100,000 linked ethylene molecules. And every time a plastic is reheated to form it into something new, some of those chains break, reducing the quality of the material. To get around this, manufacturers add new plastic to the mixture, so even recycling plastic requires new plastic. Another technique for prolonging the life of plastic is downcycling, which turns the material into increasingly less sophisticated products. Plastic that starts as a water bottle might then be turned into fleece for a jacket, before ending its life as plastic lumber in a deck. Eventually, even that isn't enough, and whatever's left gets burned for energy or thrown into a landfill. So in in a sense, there's no such thing as plastic recycling. Every bit of plastic ever made will eventually end up as waste. And in many cases, it's not possible to do even one round of recycling. And that's a big deal, considering that in 2009, about 4% of all the oil and gas extracted worldwide was turned into plastic, and another 3 or 4% was used to create the energy for that production. Now, people probably aren't going to give up plastic, and there are some good reasons to keep it around. It has huge benefits for health, accessibility, and food safety. But we can be better about how we use it, and that means developing new recycling techniques that prolong the life of the plastic that we have, cutting out single-use products where we can, and being careful about which plastics we use and how we combine them.
So there's really a lot going on that we have to account for. So rather than recycling, we often look to alternatives, like at the grocery store checkout where we're faced with a critical decision: paper or plastic. Or, if you happen to bring one, a reusable tote would be the best. Right? Here's Hank with some insight on that.
We all want to make greener choices and help the environment, but sometimes what's best for the planet can be counterintuitive. Like single-use plastic shopping bags seem to be quickly going extinct. They are now banned by stores, cities, even entire countries. And in their place are sturdier, reusable, supposedly greener bags. So problem solved, right? Well, when you look at the entire life cycle of a product, what's best for the environment can get complex. Case in point, by some measures, plastic bags can be the best option, at least if you leave out one important factor. There are all kinds of bags out there, but here we will focus on the 5 most popular: single-use plastic bags, single-use compostable or biodegradable bags, brown paper bags, and 2 kinds of heavyweight bag: thick reusable plastic bags and the classic cotton tote bag. From that list, you might think you know which bag is best, but sometimes our intuition does not line up with reality. And that becomes clear when you look at the life cycle assessment for this. A life cycle assessment is a study that looks at the full environmental impact of a product. In it, researchers study and add up each step in how a product is made, used, and disposed of. Several studies have been done like this, and the overall conclusions tend to be the same. But one major report was prepared in 2018 by the Danish Environmental Protection Agency. This report looked at 2 types of impact: climate change and total environmental impact. The climate change bit was pretty straightforward. They added up all the greenhouse gases emitted throughout the lifetime of these bags. Now, not all greenhouse gases are equal. Each has a unique potential to warm the planet, but for easy comparison, this team converted all the gases to the equivalent amounts of carbon dioxide. Meanwhile, the total environmental impact was a lot more complicated. Here, the researchers looked at 15 effects, everything from ozone depletion to toxicity to water and resource use, and a lot more. By putting a number on these things and adding them up, they could compare a broad range of impacts at the same time. The downside is that this is a big oversimplification, and they couldn't fit in some important variables. We'll get to those later. But for now, the big question is, what did this study find? Well, the first thing to consider is what it took to make the bags, because producing them is the stage with the biggest impact. Single-use plastic bags are made of petroleum, also known as oil. Specifically, this study looked at a type called low-density polyethylene, and the majority of the impact there came from turning the oil into the plastic material itself. For biodegradable plastic bags, they looked at a material called starch-complexed biopolymer, basically a plastic that incorporates plant starches. Overall, manufacturing these bags releases a similar amount of greenhouse gases as making plastic bags that aren't biodegradable. But there are also some additional effects of the agriculture involved in making the plant starches, like more water, fertilizer, and pesticide use. So just from a production standpoint, biodegradable plastic is actually worse than single-use stuff. Similarly, to make a paper bag, you need to start with a tree. How a specific forest is managed is hard to capture in this sort of comparison, but either way, the process of turning wood pulp into paper can emit a lot of greenhouse gases. This depends on what kind of fuel is used at the paper mill, so the different studies can come to different conclusions about paper bags. According to the Danish researchers' calculations, they have a similar climate impact to single-use plastic. Now, if you've been holding out for the reusable bags to come and blow everyone else away, well, they do, but not how you might think. See, thick reusable bags are also made from oil, and you need more of it to make a thicker bag, so there is a bigger impact. Heavier bags also need more fuel to transport them to the grocery store. And cotton tote bags? These might seem like a green option, but growing cotton requires a huge amount of land, water, fertilizer, and pesticides. On top of that, processing cotton is an energy-intensive process. So when it comes to making the bag, single-use plastics win by almost every measure. In this study, paper edged out single-use plastic slightly when it comes to greenhouse gas emissions, but others have disagreed with that and calculated that paper bags can be worse. And either way, when it comes to production, the worst material by far is cotton. But that said, just how something is produced doesn't really reflect real life. It's not like we're just making bags and watching them sit around in a warehouse. And that brings us to how the bags are used. Using a shopping bag doesn't cause pollution, but it does affect how we compare these materials because, like, ideally, you don't use your nice cotton bag once and then throw it away. Here, what you have to do to compare different materials is you look at how many times you would need to reuse them to offset their impact compared to using a new plastic bag every time. If we just consider the climate change impact, paper bags and biodegradable plastic bags are roughly the same as a single-use plastic bag. Meanwhile, heavier reusable plastic bags need to be reused at least 6 times to make up for their climate change impact compared to single-use plastics. And cotton bags need to be reused at least 149 times. And this isn't just something the Danish report found. These numbers are similar to the findings of a 2011 study from the Environmental Agency in the UK. To offset climate change impact relative to a single-use plastic bag, they found that you would need to use a paper bag 3 times, a reusable bag 11 times, and a cotton bag 131 times. But all those numbers change if you look at the total environmental impact. If you add in the other 15 categories with toxicity, ozone effects, runoff, and everything else. In that case, in order to be greener than a single-use plastic bag, biodegradable plastic bags, paper bags, and reusable plastic bags need to be used about 40 to 50 times each, and cotton bags need to be reused 7,100 times. That means even if you grocery shop 3 times per week, you need that same cotton bag for the next 45 years to have the same impact as using over 7,000 single-use bags. And this estimate was even higher for organic cotton because organic crop yields tend to be lower. You would need to reuse that bag 20,000 times. So there's clearly an issue with some of these materials. Like, the numbers for reusable plastic bags are well within the expected lifespan. I have reusable plastic bags that I have been using since 2004. But for biodegradable plastic, paper, or cotton bags, the number of times you'd need to reuse them is well beyond how long you would expect an individual bag to last. Now, only the Danish report calculated the total impact like this, so we don't yet have multiple studies to support those numbers. Still, just based on that, it might seem like plastic comes out ahead, and the plastic industry is happy to use this logic and these comparison studies to lobby against the regulation of single-use plastics. But there is one more key variable: disposal. Here is plastic's Achilles heel. There's no good way to dispose of it. So if you add in litter and impacts on marine ecosystems, single-use plastics look a lot less green. It's hard to get good data on what fraction of plastic bags are recycled, but we know it is low, possibly around 1 to 3%. Many recycling programs don't accept them for the simple reason that they get caught in sorting machines. And bags that are not recycled sit in landfills, clog sewers, and pollute waterways. Plastic bags are especially bad since they're easily picked up by the wind and strewn across a large area. They also take a long time to break down and pose a direct threat to wildlife. They can become wrapped around creatures mistaken for food and eaten, or even spread invasive species that hitch a ride. And this is one area that life cycle assessment studies fall short in. They don't have a way of comparing the effects of litter on ecosystems. Regardless, new materials like biodegradable or compostable bags are supposed to solve this problem. But while a 2019 study found that these are better than traditional plastics, after 3 years, none of the bags tested broke down in all environments. Paper bags are biodegradable, so the impact of litter is low, and they're recyclable, but left to break down in a landfill, they release methane, a potent greenhouse gas. For the heavier reusable plastic and cotton bags, disposal should be a smaller part of the overall footprint, since hopefully they've been reused many times. Both can be recycled, but that doesn't mean that they always are. For example, only around 15% of textiles, a broad category that includes cotton bags, end up recycled. And so now, after 3 intense rounds in a surprisingly long episode of SciShow, the greenest bag of them all it's complicated. The best material depends on many factors, including your individual habits, like how many times you reuse each type of bag and how you dispose of your bags. Overall, making single-use plastic bags has a relatively low environmental impact, but waste is a massive problem with no good solution. The best option for the end of a plastic bag's life is to reuse it as a trash bag. Presumably, you would be using something to contain the trash anyway, and if nothing else, the bag is a lot less likely to float away if it's weighed down by all the stuff inside it. Meanwhile, manufacturing paper or biodegradable plastic has higher impacts, but these materials reduce the problem of litter. And heavier reusable plastic bags are a great option if you reuse them enough. Cotton tote bags have by far the biggest environmental impact. They look very green when you've got them on your shoulder. Turns out, that's kind of a lie. They need to be reused hundreds of times to counteract their climate footprint, and possibly thousands if you consider multiple environmental impacts. So we're not saying plastic bags are good. They're not. But it is important to remember that the alternatives have an impact too. It's not worth going out to buy a snazzy new reusable product if you already have one that works. So no matter what your bags are made of, the best way to minimize their impact is to reduce how many you use and reuse them as many times as possible. And when you cannot use a bag anymore, do whatever you can to make sure it does not become litter. It's also worth keeping in mind that despite all of the attention grocery bags get, they are only a very small part of our impact on this planet. But looking at the entire life cycle of a product can be a useful way to analyze nearly any aspect of our lives, from the clothes we wear to the food we eat to how we get around. By thinking through the full effects of our daily decisions, individuals and corporations can get a better idea of the best way to reduce our environmental footprint.
It turns out there's a lot of nuance to that everyday grocery choice, but something that's not so nuanced is when that plastic makes its way into your poop. Last time I checked, I didn't see anybody eating their plastic bags, so what's going on here? Here's Stefan to tell us how it's getting there.
You just might have heard that plastics are bad for you, that you shouldn't microwave foods in Tupperware, for example, because there's nasty stuff in plastic that leaches out when you do. Now, that's not really true anymore for plastics labeled microwave safe, but it turns out you probably eat plastic all the time anyways. At least that's the conclusion of a preliminary study presented in October 2018. The findings have yet to undergo peer review, but if they're right, it would mean that plastics are already a part of your everyday meals. And that would make doctors very nervous, because we don't yet know the health effects of eating that much plastic. The problem with eating plastics is that they often contain chemicals that look a lot like hormones. When people ingest these hormone mimics, their bodies can get confused, and that can lead to health issues like reproductive problems, diabetes, liver damage, and disruptions to fetal development. So researchers from Austria were alarmed when they examined human poop samples from around the world and found actual bits of plastic in all of them. The fecal samples came from 8 of their friends, 6 in Europe, 1 in Siberia, and 1 in Japan, which I would love to hear the conversations that ended with, "Can you please overnight your poop to me?" For 1 week, the participants kept records of their food and beverage consumption and plastics they came in contact with. Then they each shipped their fecal samples to the researchers in glass jars. And all of the poops contained tiny plastic fibers called microplastics. Microplastics are any bits of plastic 5 millimeters in diameter or smaller. And they're classified as either primary, meaning they were that small to begin with, or secondary, meaning they came from larger hunks of plastic. A lot of the primary microplastics are nurdles, which is the cutest name I've ever heard for a pollutant. Nurdles are the raw pellets of plastics that are melted to make pretty much all of our plastic materials. And they're sometimes used as is to make facial scrubs and other exfoliating skin products, although the practice is now banned in the US, Canada, New Zealand, Taiwan, and some European countries. Nurdles escape into water systems like nobody's business, and they can also be the secondary sources of microplastics because they lack the UV protection of finished plastics, so they degrade easily. Secondary microplastics are the ones that flake off from cracks in the surface of larger plastic pieces, which form as the plastic degrades. Usually when you hear about microplastics, it's because they're water pollutants. Aquatic microplastics were first noticed in the early 1970s, and since then they've been found in nearly every water system, even the oceans surrounding Antarctica. And they're especially good at delivering toxins, because they can pick up other contaminants from the water. Their high surface to volume ratio, plus their tendency to be slightly hydrophobic or water repelling, mean they readily absorb other highly toxic pollutants. And then, when the particles are eaten, they deliver a concentrated concentrated dose straight into the body of the creature that consumed them. It's not yet clear how damaging the microplastics found in aquatic habitats actually are, but laboratory studies have suggested consuming them can cause serious health problems for lots of important species. So understandably, biologists have become concerned that they found microplastics in the bodies and droppings of all sorts of aquatic animals, from shellfish to seals. And if that's not bad enough, a lot of these compounds, and maybe even the tiny bits of plastic themselves, tend to stick around and concentrate in an animal's tissues. So when a bigger animal eats a lot of smaller animals that have a bunch of these bits of plastic inside of them, the bigger animal will get a larger dose, and so on up the food chain until they're eaten by people. Which brings us back to that study. The big question on everyone's minds is where the plastic bits came from. Since they were found in the participants' poop, they must have somehow consumed them. The whole plastic in marine animals thing might suggest a love of seafood is to blame, but only 6 of the participants reported eating fish or shellfish. In fact, the vast majority of microplastics are thought to form on land, because that's where plastics are exposed to the most intense sunlight and heat. And they can also be found in the air. Plastic fibers in carpeting and our clothing contribute to microplastic dust, which, like your garden variety dust, can become airborne and then settle on things, like your plates or food. Studies have suggested that you're exposed to a lot more microplastic via dust than your favorite mussel linguine. If dust was the source of the plastic particles seen in the study, it could be a tiny silver lining, as air-based microplastics may not absorb other contaminants like aquatic ones do. But even the best case scenario here isn't good news. The presence of plastic in human poop suggests that even when we think plastics have broken down and disappeared, they're still around, just in microscopic form. Not only are they in our waters, they're apparently in or on the food we eat too. And the plastics in our world aren't going away anytime soon, which in many ways is a good thing. Plastics have allowed us to do great things in terms of medicine and technology. But if most or all of us are eating microplastics all the time, a lot more research is needed to understand where they come from, what chemicals they contain, and ultimately how they affect our health.
So before becoming poop, it was food at some point. You could have been eating it with your hands, off a ceramic plate, or in a plastic bowl, and you might have noticed that some of those food containers have a label where they proudly claim to be BPA-free. What does that mean? What is BPA? And how scary is it really? Let me explain.
Maybe you've seen those BPA-free stickers on plastic water bottles before. Having them labeled that way makes it seem like a dangerous chemical, but you can find BPA in all sorts of things. DVDs, shatter-resistant eyeglasses, baby bottles. It's even in resin that lines some cans of food and in thermal paper receipts that you get at the store. Most people have detectable levels of it in their urine, and that hasn't caused the collapse of civilization, although 2016 may have come close. Anyway, how bad can BPA actually be? Even though there's been a fair amount of research on BPA, we still don't know if it's completely safe. BPA is short for bisphenol A, and it's one of the most common ingredients in a type of hard, clear plastic called polycarbonate. You can react it with another chemical, like carbonyl chloride, to form long chains, and those chains form a really durable plastic. Those chains are pretty chemical inactive, but the trouble comes when unreacted BPA molecules stick around in the plastic. When you heat it up, like by putting a plastic container in the microwave, those leftover molecules can become free. And that is what might be a problem. See, BPA is what's known as an endocrine disrupting chemical. It's a molecule that interferes with how natural hormones like estrogen, androgen, and thyroid hormones work in the body. Animal studies have linked BPA to all sorts of problems, like decreased fertility, impaired fetal development, obesity, and cardiovascular diseases. But like with any health research, you can't just translate those findings to humans. For one thing, laboratory conditions don't mimic the way we interact with BPA very well, in terms of dosage or exposure. Plus, not all those research results have been reproducible. Lots of studies have found BPA is bad, but they don't always agree on how or why. Right now, the US Food and Drug Administration sets the safe level for BPA exposure at 0.5 microgram per kilogram of body weight per day. But some scientists are saying that that limit is still too high. Because BPA is a hormone disruptor, it might act differently from other toxic substances. Usually more of the bad stuff means more bad news for your body. A tiny bit of cyanide is okay, but a lot of cyanide is not. But chemicals that target the endocrine system have been known to break that rule. According to some research, a low dose of some chemicals might be worse than a high dose, because if the body suddenly detects a high dose, it knows something's up and won't respond. So while BPA isn't definitely terrible for humans, it might not hurt if manufacturers phase it out, especially when it comes to things like baby bottles, as long as we study the new replacement plastics just as carefully.
But whether it's BPA-based or not, a lot of our plastics end up in the ocean, and engineers and researchers are working to find potential solutions to get as much as possible back out again. Here's Hank with more.
Since it was invented over a century ago, plastic has become an established part of human life. It's built into our houses, our vehicles, our food containers, our clothing, and unfortunately, our oceans. It's a really big, bad problem, but there are some solutions that might help. An estimated 4 to 12 million tons of plastic washes into the oceans every year, and this debris causes lots of problems. Marine animals get physically tangled in larger waste, and hundreds of species ingest smaller bits of plastic, mistaking it for food or accidentally swallowing it, which can kill them. Plus, some plastics contain harmful substances like bisphenol A, PCBs, phthalates, and even flame retardants that can leach into the ecosystem and move up the food chain. It can take hundreds of years for plastic to fully degrade, and because microplastic is about the same size as a lot of the plants and animals living in the water column, it's extremely difficult to filter out. Ocean currents send a lot of this garbage to one of 5 patches, or gyres, in the Pacific, Atlantic, and Indian Oceans. The Great Pacific Garbage Patch, for example, is twice the size of Texas and lives somewhere between California and Hawaii. Researchers estimate that combined these 5 patches contain anywhere from 500,000 to 200 million tons of plastic. So one option would be to start cleaning up the oceans by targeting these monstrosities, like the Ocean Cleanup Project developed by Boyan Slat when he was a teenager. After many research expeditions, Slat came up with a giant V-shaped prototype. Each arm of the V is a floating boom with a trailing submerged screen designed to passively collect debris using ocean currents. As water moves through these long floating barriers, lighter than water plastic gets caught in front of the barriers. Meanwhile, the screens under the surface catch smaller submerged plastics, while sea life can safely swim beneath the screens. From there, plastics get funneled toward the center of the collector, where a central platform extracts, stores, and eventually recycles it back on land. The Ocean Cleanup Project hopes to deploy a smaller scale model off the coast of Japan later this year to test things like the barrier's durability and efficiency in real-life conditions. But some oceanographers worry how Slat's system will affect sea life and how unmanned stations will withstand brutal ocean storms. Others are trying to find the best places to set up plastic removers. Researchers from Imperial College London found that it could be more effective to recapture debris closer to shore before currents carry it out to the middle of the ocean where it's harder to collect. They ran a series of computer simulations using a model of 29 hypothetical floating trash collectors, or sinks, similar to ones produced by Slat. Their model took into account things like ocean currents, where the trash was coming from, and the distribution of phytoplankton and other marine life. When they ran the simulations with the sinks in different test locations, they found that placing the sinks in certain offshore areas, mostly off the coasts of China and Indonesia, would remove about 31% of all ocean plastic by 2025. The sinks would catch plastics as they entered the ocean, as well as debris swept along by currents. Meanwhile, models of sinks deployed around the Pacific Garbage Patch only cut trash by about 17%. Plus, the simulations showed that the sinks closer to the shore, as opposed to the open ocean, had less of an impact on marine life. But even if these methods work and make a significant dent in sea trash, new plastic is always coming in. Australia's National Science Agency recently completed a massive 3-year study of ocean trash and estimated the world doubles its plastic production every decade. That's probably why, at least for now, many experts agree the best solution is to just stop all that plastic from getting into the water in the first place. About 80% of ocean trash comes from land, and most of it consists of water bottles and plastic packaging. And there are ways to reduce that trash. Things like being less dependent on plastics, making sure waste is disposed of properly, and putting up catch nets around storm drains. No matter how we do it, cleaning up the oceans will be hard. But by preventing as much plastic as possible from getting into the oceans in the first place, and by collecting as much as we can of what does get in, we might be able to make some progress.
So, although plastic is extremely useful in our everyday lives, it can get literally everywhere. And we're going to need some creativity to make our planet a little less plastic. If you enjoyed this compilation, you might also enjoy this one about trees and all the great things they do for us, from making oxygen we breathe to literally holding the earth together. Thanks for joining us. We'll see you next time.